This is the solution video from question 7 from section A of the 4th sample test for CSAT. In this question, we're told a function f is defined recursively for all integers n greater than 1 and p greater than 0 as follows. f1p is equal to c plus p, fn1 is equal to c, and f of np is equal to f of n minus 1, f of np minus 1, and we're told in this description c greater than 0 is a real constant. Given all this, we're asked to find a non-recursive expression for f4p. I'm actually given a hint in this question as well. We're told to first look at the case of f2p and proceed with that first. So we're going to start with following the hint. We're going to look at f2p first. So we're going to assume p is some general p here, that it's not any specific value, and we're going to try and work it out for this. So if p is 1, we're in a special case of case 2, but if not, we're going to have to use case option 3 for a rule to apply. So looking at option 3, we know f2p is f of 1, f of 2, p minus 1. Well, f of 1, p is c plus p, so this will be c plus f of 2, p minus 1. Now, if p minus 1 is 1, we use rule 2. If not, we can just apply the same logic, because we jumped from f2p to c plus f2p minus 1. So that implies if we do it again, we get 2c plus f2p minus 2. And we can carry on with this all the way until we get to a 1 here. So we'd get p minus 1 lots of c plus f2, 1. So we could prove this rigorously if we want, but we're not asked to do this in this question, so we can just write this down. So where do we go from here? Well, f2, 1 is crying out for rule 2, so let's use rule 2, so we know it's just c. So p minus 1 times c plus c, and we obtain pc. So we know f2p is pc. So how does this help us in our aim to get f4p? Well, let's think what made this work. The crucial step here is that f2p is equal to f1, f2p minus 1, but we know what this looks like in a different form. We know how to expand out, so to speak, f of 1 something. We just write c plus the thing. And that let us get f of 2, because we could just reduce the n value by 1 and expand it all out. But now we've got a rule for f2 of p equal to pc. So if we look at, say, f3 of p, we've got this rule that tells us that when we go from 3 to 2, how to expand all that out. And we can probably do something similar for f3p that we did for f2p. So let's look at f3p with our new rule that we worked out last time, written here, that f2 of p is pc. So f3p, we've got to use rule 3. So we know it's equal to f2 f3p minus 1. And now we can use our new rule 4 to obtain that this is c times f3p minus 1. And if we do that again, we know f3p minus 1. Well, we can just use the same process again. So we get f3p minus 2, and we generate another c for c squared. And we carry this on until we get a 1 here. And if we do this recursively, we get f3, 1, c to the p minus 1. And now we have to be a little bit careful, but we see that we don't use rule 4, we have to use rule 2. So fn1 is c. So f3, 1 is c, so we get c times c to the p minus 1, c to the p. So f3p is c to the p, and now using this rule and the same methodology, we should be able to work out f4p. So here's f4p with our new rule 5, f3p is c to the p, and let's try and make a bit of progress. So as before, let's use rule 3 first, so f4p is equal to f3, f4, p minus 1. And we'll utilise the rule 5 we've got now, that we can rewrite this as c to the f of 4p minus 1. And if we did that again, well, f 4p minus 1 we can write as c to the f 4p minus 2 by the same logic we used here, to get c to the c f 4p minus 2. So how do we progress from here? Well, we know if we carry on doing this, we're going to get something looking like this. C to the c to the c, all the way up to c to the f4 minus 4, 1. How many c's are we going to have? Well, we can just carefully count. So when we decrease p by 1, we have 1 c. When we decrease p by 2, we have 2 c's. So in this case, we decrease p by p minus 1. So from here all the way to here, we'll have p minus 1 c's. And now we just need to utilise the final part of f and 1 is c. So f4, 1 is c. So we end up with c to the c all the way up to here with p c's in this expression. And this is our expression for f 4p as required. And so we're done. And this is our answer.